Hello, so I'm going to show you guys how you guys will do the Algor Mortis activity and the math that is involved whenever we're doing Algor Mortis calculations. So the way we get these temperature values is by sticking a probe into the decedent's liver. So whenever we have a body at a crime scene, we're going to put a probe into the liver, read the temperature, and then we can use calculations, which are fairly accurate. It just depends on a lot of stuff, to figure out how long that person has been dead. There are lots of things, which you guys will see in the notes, that can affect this, but we're going to assume for our problems that we're working with a normal temperature, normal conditions. So there's no weird scenarios, unless the problem has told you that there is. So I'm going to show you guys 4 examples in this video. These are all the possible scenarios you would be given, okay? So it's going to be an example that will be less than 12 hours since the person has died, more than 12 hours because there's more steps involved if they have been dead for longer than 12 hours. And then if you're given scenarios where the temperature is unknown, but you're given the time since they died, you can still figure out how those would be calculated as well. So this video is super helpful for you because it will give you all of those, and then you just change the values on your own because you'll still follow these same steps for every problem. It'll just be different numbers that you're getting. So you will want to have a calculator handy. I would highly recommend that you're doing this with me versus just watching the video and then trying to figure it out later, because it will make a lot more sense. It'll make you have a lot less questions as you're working through the activities that are associated with these types of problems. Okay? So the first thing I'm going to do is I want to have this picture here constantly ready. Okay, so this is in your guys' notes, it's in your slides, and it's going to be, I think I have it posted online. If not, it's in your slides for sure, but you're going to be adding it to your notes as well, so it'll also be in your notebooks. This is the greatest reference that you're going to have. Thankfully, in this class, I do not expect you guys to memorize anything because in the real world, they don't. So have this handy for every problem that you do. That way you don't have to memorize all the steps because there are quite a bit. And you also don't have to memorize the numbers that are associated with those steps in order to finish your problem, okay? So the first thing we're going to do is start with step 1. In this problem, I'm going to show you guys both Fahrenheit and Celsius in case you're given one or the other in a problem. And then you guys can just work with whatever. If you're given a problem where you have both, choose whichever one you may have like more comfort towards. I like to work in Celsius because that's the scientific value and usually that's what you're given. But if you prefer Fahrenheit because that's how we know temperature now, then you are free to do that as well. It's whatever makes you comfortable, but just make sure you stick with that value the entire problem, because if you're switching back and forth between Fahrenheit and Celsius, you're going to get the wrong answer. Okay, so first step, subtract found body temperature from the normal. So our normal body temperature, if I go with Fahrenheit, is going to be 98.6 degrees Fahrenheit, okay? And our found temperature is the 83.2 degrees Fahrenheit, okay? So that is what we found when we put the probe into the liver. What I'll do then is I'm going to subtract those two, get my handy dandy calculator out, and I'm going to get a value of 15.4 degrees Fahrenheit, and this is how much temperature has been lost, okay? This number here, 15.4, is smaller than the number we found in step 2, okay? So step 2 is just saying, based off what you guys read in your previous section, that for every hour, for the first 12 hours, so for the first 12 hours, we are going to lose body temperature at 0.78 degrees Celsius per hour, or if I'm working with Fahrenheit, 1.4 degrees Fahrenheit per hour. So that's my first 12 hours, okay? After 12 hours, we lose them at half that rate. So in other words, it's not losing the temperature as quickly because we're getting closer to whatever the surrounding temperature is, and so it slows down the rate at which you're losing temperature. Okay, so that would be in this scenario 0.39 degrees Celsius per hour or 0.7 degrees Fahrenheit per hour. And if you see, those are literally just half as much as they were before. So we lose temperature half as quickly after 12 hours have passed after we died. Okay. So in this scenario, if we were to use the 1.4 and multiply it times 12, that would get us the 16.8. If I was working with the Celsius, that would be 0.78 times 12, and that would get us 9.4. So the step 2 values will always be the same. It's always going to be in the first 12 hours, they'll lose 16.8 degrees Fahrenheit or 9.4 degrees Celsius, okay? And that's just a number you can memorize or always reference here. So then what you'll do is you'll take the 16.8 Oh, sorry, never mind. Look at the 16.8 compared to the value we have. If the number is smaller, so if you see right here in the red, if step 1, so the 15.4 we found, is smaller than step 2, 16.8, you divide for step 3 by that value. So 1.4, and then we're done. That's all we have to do for that problem, fairly simple. So I'm going to take 15.4, and I'm going to divide it by, well, actually 50.4 degrees Fahrenheit divided by 1.4 degrees Fahrenheit, and that is going to give us a value of 11 hours. Okay, if I did this in Celsius, which I'll show you guys real quickly how we would do that, I would take the 37 degrees Celsius, because we're going to subtract the found body temperature from our normal, and that's our normal in Celsius, and we have 28.4 degrees Celsius for our found temperature, and that is going to give us a value of 8.6 degrees lost. And then we're going to take the 8.6 degrees Celsius and divide it by the 0.78 degrees Celsius, and that is going to give us a value of also 11 hours, because this should not be different. If we have Fahrenheit or Celsius, it should be the same value. So for our answer, 11 hours have passed since our person has passed away in normal conditions. Okay, so it's very important that you remember that part. All right, so let's do the next one. So this one I'm just going to do in Fahrenheit just for time's sake, so you guys are not having to watch this video and feel like it's going on forever. But I'm going to show you guys how to do this one, and we are going to move on to the next ones after that. Okay, so this one is going to require a few more steps. So we're going to follow 1 step, 2 step, 3, 4, and 5. We're not going to skip over to the red font. Actually, we're just going to keep this guy up here because it's looking weird. Okay. So I'm going to work on Fahrenheit. So first step is the 98.6 degrees Fahrenheit, subtract the found that we have. So in this case, 75.6 degrees Fahrenheit. Okay, when I get those two, we have lost 23 degrees Fahrenheit. Okay, so that's how much temperature has been lost since they've passed away. This 23 degrees Fahrenheit is bigger than my standard temperature in step 2, 16.8. Okay, so what I'm going to do is figure out how much has been lost after those 12 hours. If I know what I have lost in the first 12 hours, I need to figure out what's the difference after that. So I'm going to take the 23 degrees Fahrenheit, okay, and subtract the known amount, 16.8 degrees Fahrenheit, for the first 12 hours. So we're only looking for that snippet of time. We already know what 12 hours has given us, okay? When I do that, I'm going to get 6.2 degrees Fahrenheit lost after 12 hours. I'm going to write this because I'm going to forget when I have to do one more step at the end. Unless I have my steps handy, then I'll remember, okay? So 6.2 degrees Fahrenheit was lost after 12 hours, okay? So then what I'm going to do is I'm going to now divide by the value after 12 hours. So remember we said after 12 hours there's different values, okay? So I'm going to take 6.2 degrees Fahrenheit and divide it by 0.7 degrees Fahrenheit. And that is going to give me 8.86 hours, okay? So we know that after 12 hours, an additional 8.86 hours have passed, okay? So that means if in order to get my total time since death, I need to take the 8.86 hours and add, back the 12 hours, and that's going to give me a total of 20.86 hours, but I'm just going to round to 21 hours because if you did this problem in Celsius, you'd get 20.72 instead, but that still rounds up to 21. So we're just going to round to whole numbers with these problems, mainly just because it's hard to figure out 0.8, 0.9 in minutes. So we're just going to say it was 21 hours since they passed. Okay, so 21 hours. Awesome. Okay. So that's if we were given a temperature. This is normally what we're going to have because at a scene, we don't already know how much time has passed usually since someone passed away unless there's like a video recording or something about it giving us information. Okay, so let's say someone told us, oh, it's been 7 hours since they died. Let's figure out what their body temperature should be based off that information, okay? So with these types of problems, it's a little different. We're not going to follow the steps up there. We kind of have to use a little bit more thinking, but if you guys follow these steps from in this video, you should be fine. Okay, so 7 hours. So we know that we lose our temperature at let me write this down. So 0.78 degrees Celsius per hour. Or if we're working with Fahrenheit, 1.4 degrees Fahrenheit per hour. Okay, so then basically what I'm going to do is I'm going to take 0.78 degrees Celsius and times it by the 7 hours, and that will give us our answer, or the 1.4 degrees Fahrenheit and times it by 7 hours, and that would also give us our answer. So what we end up getting is 88.8 degrees Fahrenheit, or if we're working with our Celsius, we end up getting 31.54 degrees Celsius. Okay, so that would be our answer in that problem. Okay, pretty simple. All right, so then what we're gonna do, there's an additional step also with this one because more than 12 hours have passed, so we have to use two different ratios. So what we're gonna do first is figure out how many hours past 12 hours. So we know 4 hours have passed after those initial 12 hours. And then what we're gonna do is figure out the ratio. So if we're working with the ratio for this one, we're gonna actually have where it is 0.39 degrees Fahrenheit, Celsius, right? 0.39 degrees Celsius per hour, or 0.7 degrees Fahrenheit per hour. Okay, so using our ratios from the after 12 hours instead. Then what I'll do is we know we have 4, so we're going to take the 4, times it by 0.39 degrees Celsius, 4 times our 0.7 degrees Fahrenheit, and that is going to give us a value. We get 1.56 degrees Celsius. Okay, and then we have 2.8 degrees Fahrenheit. Okay, and then that's what we have after 4 hours, so we have to add back the value of those first 12 hours. So in Celsius world, that's going to be the 9.4, so we're going to do 9.4 degrees Celsius plus 1.56 degrees Celsius. And in this problem, we are going to take the 16.8 plus 2.8 Fahrenheit, sorry. And that is going to give us 19.6 degrees Fahrenheit lost. Okay. And if we're working with Celsius, that's going to be 10.96 degrees Celsius lost. Okay. And now that we have those, we have to add back our standard temperature. We have to figure out what the temperature would be. So we're going to take the standard normal temperature of Celsius and 98.6 degrees Fahrenheit. And we're going to subtract the numbers that we found, 10.96 degrees Celsius. And then we're going to have 19.6 degrees Fahrenheit. And that's going to give us 26.04 degrees Celsius. Or 79 degrees Fahrenheit. Okay, so this would be the temperatures we would get if we had measured them at the crime scene. Okay, so those are our answers for all of those different scenarios. The biggest thing to remember is to have the steps available and make sure you are really paying attention to the numbers you are getting each step, because that's going to tell you, do I keep going all the way through all steps 5, or do we actually do an alternative in the red on our notes? So, and I am looking forward to see you guys very shortly.